Good morning. This is Ms. Billerbeck, and we are going to do 9.2, solving quadratic equations by factoring. The zero product property states that for all real numbers a and b, if a times b, or ab, equals 0, then a equals 0 and or b equals 0. So if x squared minus 7x plus 14 equals, in a factored form, x minus 2 times the quantity x minus 7, and that equals 0, then either x minus 2 has to equal 0 and or x minus 7 has to equal 0. So either one of these has to be 0 or both of them. So if that's the case, 2 minus 2 equals 0, so x minus 2 would be a solution. Oh, and if you're wondering what these are, the 3 dots, that means that they're 4 in fancy math jargon. So we have either equals 2 and or 7 minus 7 equals 0, so x would have to be 7. So let's go look at a few examples. So let's solve each equation. So one of these has to equal 0 or both of them. So let's set one of them to 0 and figure out what that value of x should be. So we're going to use an additive inverse here. I'll abbreviate that with an A. And I have 2x plus 0 equals 1. So now I'm going to use a multiplicative inverse, which I'll abbreviate with an M. And I'm going to, since 2 is multiplying x, I'm going to divide by 2, the opposite operation, and that'll cancel that out. So I have x equals 1/2. Okay, so 2 times 1/2 is 1. 1 minus 1 equals 0. So let's do this other one. X plus 3 equals 0. So my additive inverse for this will be -3, because 3, positive 3 minus 3 equals 0. So I have x plus 0 equals -3. So x equals -3 is my other solution. So I can write this with wavy brackets and say -3, 1/2 if I want to use the higher level math jargon of representing a set of solutions. Okay, so this one we have 2x plus 3 might be 0. So we're going to use an additive inverse here and do a -3 on one side of the equal sign and a -3 on the other. And we get 2x plus 0 equals -3. Now I'm going to use a multiplicative inverse, divide by 2. That cancels that out. And I get x equals -3/2 for one of my solutions. Now let's see what this one might be. So I have 3x minus 1 equals 0. I use an additive inverse of +1. And then I get 3x plus 0 equals 1. I'm going to use a multiplicative inverse, divide by 3. And I get x equals 1/3. So my set solution for this one will be -3/2, 1/3. All right, so that's how we find our zeros or solutions, or they'll be roots pretty soon. So, all right, so let's solve each equation by factoring now and see if we can find the roots in the solutions in the zero product properties. Okay, so if we look at this, we have 8 squared. We have x squared here. So 2 times x times 8 does equal 16x. So that means this is a perfect square trinomial. So we have x plus 8 times x plus 8, otherwise known as x plus 8 squared. So that means we can set x plus 8 to 0 since this is equaling 0. And we're going to use an additive inverse here. And we get x equals -8. So that's one solution, -8. So what that means as far as a graph is if I have a y here and an x here, I have a parabola coming down and it's going upward because that's a positive value of a. So it's going upward, but it meets the x-axis at -8. All right, so that's what this would look like, this quadratic. So that's the solution or the root or the zero product property. There you go, or solution. Okay, this one is not set to 0, so we need to do that by subtracting 64 from both sides. So we have x squared minus 12x minus 64 equals 0. Now we can work with this, but hold up. Look at this. This is not a plus sign. So this is not a perfect square trinomial. There's no perfect square trinomial with a minus sign here. So we're going to have to do the A, B, C factoring. So 1 times -64 is just -64. And then we have -12 here. So we want to look at factors and sums. Okay, so the factors, we have two, we're going to have one negative, one positive to make this a -64. So if we went with 8 and -8, well, that sum would be 0. So it's not those. So the bigger number needs to be negative because we have a negative sum. So let's try -16 times +4 because that equals -64. So that does add up to -12. So we can put a -16 here and a 4 here. Because A is 1, we don't need to do the box. We can go straight from here and say, oh, this factors is as x minus 16 times x plus 4. So now we can solve for two different zeros. X minus 16 equals 0. So we add 16 to both sides using an additive inverse. And we get x equals 16. That's a little additive inverse. We also have x plus 4 equals 0. We use an additive inverse here, and we get x equals -4. So for this, we have two solutions, -4 and +16. And we have a graph that's going to look like this. So we are way down, our y-intercept's way down at 64, but we're only at -4 right here. So it's going steeply down here and then coming back up this direction. Okay, so this point here, this is y, this is x. Let me zip that one up. Then this is -4 right here. This is 16. But remember that we have a y-intercept in our quadratic, standard form of the quadratic. So that's -64 if we were to look at the graph. Okay, so that's what these solutions mean. So we hit the graph in two spots on the x-axis. All right, let's take a look at a real life problem. All right, so we have a picture frame here. And the picture is 375 centimeters. The outside of the picture with its frame is 20 centimeters by 30 centimeters. But we don't know how wide the frame is. So we're going to say X is the frame width and it's X all the way around. So if we look at this length here will be 20, this 20, minus this X and this X, because this 20 goes from here to here. So this would be minus X plus 20 minus X, which is 20 minus 2X. This full distance here is 30 centimeters. So the distance from here to here would be negative X plus 30 minus X. So that's 30 minus 2X. So let's write that out as a length times width. So we have a length of 30 minus 2X times a width of 20 minus 2X equals 375 centimeters squared. So let's do FOIL. So we're going to do 30 times 20, which is 600. 30 times negative 2 is negative 60X. Negative 2X times 20 is negative 40X. And negative 2X times negative 2X is 4X squared. And we are going to subtract the 375. Let's do that from both sides at once so we can save some time. So we'll subtract 375, and then that equals 0. Right, let's reorder this into standard form of an equation. So the 4x squared is the highest degree monomial, so it goes here. The next higher degree would be the x term. So let's combine them. Negative 60x minus 40 is negative 100x. And then we have 600 minus 375 is positive 225, and that equals 0. Now, if this was a wonderful problem that was super easy, we'd notice that this is 15 squared, this is 2 squared. Is this 2 times 2x times 15? Is it? 4 times 15 is 60x. So no, we didn't get lucky. It is not a perfect square trinomial. So we can't just factor the easy way. So they don't have a common factor since this is an odd one. So we can't take a 4 out of everything or a 2. So we're going to do some factoring. So we have A, B, and C. So A times C is 4 times 225. That happens to be 900. And B is just negative 100. So when we look at factors and sums, so we have, most likely, we have 2 negatives making that positive. Otherwise, we'd have a negative times a positive to get this negative. So we have 2 negatives times a positive. So let's try 30 times 30. And that's 60 when we add them together, but that equals 900. That didn't work. So let's try 90. Oh, and these are negatives. So that's negative 60. So let's try negative 90 and negative 10. Well, that does give us negative 100. So we found it. So let's go ahead and do the box. So our first term's 4x squared. The last term's 225. Then we have the negative 90 goes here, negative 10 goes here from this here. And so we put negative 90x, negative 10x. And remember, this was a negative times a negative to make that 225, okay? So So we're going to put that there so we have those to distribute. So 10 and 225, negative 10 and negative 225 have a negative 5 in common. 4x squared and 90x have 2x in common. 4x and 10x also have a 2x in common. And 90x and negative 225 have a negative 15 in common. So we just found how it factors. 2x minus 5 times 2x minus 15. And that's going to equal 0. So it looks like we are going to have two solutions. So we'll have to think about reality when we look at the solutions. So our first one is that 2x minus 5 equals 0. So if we add 5 to this side, we get 2x equals 5. And then we have to divide by 2 on both sides. So this gives us x equals 5 over 2, or 2.5 centimeters. Okay, that's realistic. Okay, so let's check the next one. So we have 2x minus 15 equals 0. We add 15 to both sides. So we have 2x equals 15. We divide by 2, and we get x equals, and that's going to be 7.5 centimeters. That's a little large, 7.5 centimeters. So if we get a meter stick out, so let's look at reality here. We would have 2.5 centimeters is here. 7.5 centimeters is there. Actually, both of those would be realistic picture frame widths, depending on how large your picture is. Okay, but for 20, now let's think about it. We know that the large picture frames are for large pictures. Oops, let me get this back the right way. So let's look, this is 20 centimeters. Okay, that's not very big. This is 30 centimeters, okay? So would we want a big picture frame on a 20 centimeter width picture, okay? Or would we want a little picture frame of 2.5? So probably for this little picture, we probably want to go with 2.5 centimeters. All right, so I am going to say the answer is the frame is 2.5 centimeters. Okay, it could be 7.5 centimeters if you had a big wall and you wanted to expand the little picture to take more room. Okay, but realistically, it should be 2.5 centimeters. All right, so let's go ahead and take a look at this. So we have f of x equals 2x. Looks like it got a little erased here. So we have 2x plus 5x minus 3. So we want to factor that and then graph it. So we're going to take a little diagonal here. We have 2 times negative 3, which is negative 6, and then we have 5. So we know that only one of the numbers is negative to make a negative 6. But the sum is positive, so the bigger number is the positive number. So that's 6 and negative 1. Because this is not 1, we're going to have to use the box. So let's take a look at the box. So we have 2x squared minus 3 Then we have 6x and negative 1x. So we have a negative 1 here. This is a 2x. This one we have just x in common. And this one we have 3. So we have a plus 3. So let's find our roots. So this is factoring as 2x minus 1 and then x plus 3. So we set those equal to 0, 2x plus, it's a minus 1, equals 0. So we're going to add 1 to both sides. We get 2x equals 1. We're going to divide by 2. So we get x equals 1/2. So we have our first point of the graph is that x equals 1/2. If this is 1, that's 1/2. Right, the next one we're going to look at is x plus 3 equals 0. So we subtract 3 from both sides, and that gives me x equals negative 3. So I have a point on the graph here. Now from the original equation, I also have negative 3. One thing I know about points on a quadratic or a parabola is the axis of symmetry is halfway. So if these are 3.5 inches apart, then 1.25, so that's 1.25. So let's see, 3.5 inches apart would be 1.75 would be halfway. So 1 plus the half is here, plus 0.25 is right about here. So we've got an axis of symmetry that's halfway here. So we can graph that. That's a wonderful thing about finding the roots is you can find the axis of symmetry by taking the average of the two and finding where this is. Okay, so we have an axis of symmetry here. And that's at 1.75. We also know that if this is 1.25, then that is probably right there because we're using the axis of symmetry. So we just need to know where that vertex is, but we can find it. Well, we know we're dealing with negative 1.75, and we can quickly check that with the negative b over 2a. So 5 over 4 is 5 over 4, that's 1 1/4. Negative 1 1/4, which is just exactly where we are. Okay, so we plug that back in to find where this low point is. So we have f of negative, let's keep it 5/4, equals 2 times 5/4 squared plus 5 times 5/4 minus 3. So let's do a quick calculation. That's 2 times 25 over 16 plus 25 over 4 minus 3. So this cancels, that's an 8. We're going to go do a 2 over 2 here. So we've got 25 over 8. That's a funny looking 8. Sorry about that. And then we have plus 50 over 8 minus 3. So I have 75 over 8. So how many 8s in 75? So we know 8 times 9 is 72. So that's going to be 9 3/8 And then we have, oh, that's a negative. So this is a negative number. So sorry. And I was like, that doesn't make sense because it needs to be down here. So it can't be a big number. So that helps when we make a mistake, we know to check, did we forget a negative? Because that's usually the problem. So that gives me negative 25 over 8 minus 3. So now I know there's 3, negative 3 and 1/8. So minus 3 gives me negative 6 and 1/8. So I've got my vertex. Yay, I can just finish this parabola. Yay. Okay, so that's how we do it. So 1/8 is very small, so we're right here. And then we graph like this. So it's a very steep graph going up. Okay, so that's how we graph using roots. We can find the middle where the axis of symmetry is. We can use that axis of symmetry to find the vertex. All right, so this leads us into factored form of a quadratic. So the factored form of a quadratic is A times the quantity x minus p times the quantity x minus q equals 0. So A again is your vertical stretch or compression, but p and q are your zeros or your roots or your solutions to the function. So we can quickly find the factored form of this graph because we can look at where does it hit the x and axis. So it hits here at 3, 0, and it hits here at 9, 0. So we have f of x equals, and then we have a times, and we could just put 1 is our p is 3 and our q is 9. So we can put x minus 3, x minus 9, like that. So now if we just put some value of x and y in there that we know, which we know this one, this value is 6, negative 9. So our output's negative 9. And we have a times 6 minus 3 and 6 minus 9. So that's negative 9 equals a, and that's 3 times negative 3, which is negative 9, equals a times negative 9. So when we divide by negative 9, 1 equals a. So our stretch is just 1. So the equation for this is f of x equals x minus 3. Actually, let me get some more room here so you can really see it. So f of x equals x minus 3 times x minus 9. And there we have it. That's it for this lesson. Have a wonderful day. Bye-bye.